Hello everyone. Welcome to the sessions on the advanced communication. This is the session 1 in the unit 1, that is microwave devices. The contents which we are going to cover in this particular session are frequency bands which we are using in the microwave, advantages of the microwave, disadvantages and the challenges of the microwave, applications. These are the topics which we are going to cover in the particular session here. That is, if you consider the microwave signals, microwaves are the signals with frequency greater than 1 gigahertz. The frequencies which are greater than 1 gigahertz, those are called as the microwave frequencies, and usually it is extended up to 30 gigahertz. Usually it is extended up to 30 gigahertz, and that is called as the microwave signals here. Now, if you observe the frequency bands we use in the microwave are here, these are the radio wave frequency range here, these are the microwave here, up to 10 raised to minus 2, 1 to 10 raised to minus 2 here, and these are the infrared, like this, different X-rays, these are the different bands here. Now, this is our microwave frequency band here. If you observe here, this is our microwave frequency band. Now, these are the frequency bands. Very low frequency means it is called as the VLF, 3 to 30 kilohertz. Similarly, low frequency means it is 30 to 300 kilohertz. Medium frequency means 300 to 3000 kilohertz. Like this, the chart is there depending on the what are the different frequency, the symbols which we are using, and the frequency ranges which are associated with that particular symbols here. Following this one, this is the different frequency names here. Super high frequency, ultra high frequency, very high frequency, extremely high frequency, like that. These are the names. Names are given, and here the symbols are there, and here it is the frequency ranges are present here. Now, again, suppose here this is the microwave frequency range here, and this is the infrared, UV, and the X-ray. Okay. Now, why we are calling it as the microwaves here? That is why we are calling it as these are the microwaves. For example, if you consider the waves, suppose this is one waveform here, correct? This is one waveform. Now, microwaves means what? Higher frequencies. Higher frequencies means what? The time period will reduce here. Now, see here. Now, this is one frequency. Again, this is one more signal. Again, this is like this, one more signal. Among these, all these signals, which is having the highest frequency? Last one is the highest frequency. Last one is the highest frequency means it is very minute time period, very small. Micro means small here. Correct? Micro means small. Therefore, here if you observe here, we will get is a small waveform here. Small duration of the time. Therefore, these signals are called as the microwaves here because the frequency is high here. For that reason, these are called as the microwaves here. Now, advantages of the microwaves. What are the, why we have to go for the microwave? Why not below the microwave only for the higher frequencies? Why we cannot operate? What are the advantages here? First one, the bandwidth available in the microwave frequency is very large. The bandwidth available is very large. Therefore, for any application, we can make use of the microwave signals here. Second one is the better directivity. Means they are having the directivity such that very sharp directivity there. Wherever intended for to that particular point, it can be radiated here. Therefore, the better directivity. Next is the small size antenna, because as we know, as the frequency increases, antenna size reduces here. Both are inversely proportional. Therefore, if the microwave means very high frequency signals, these are frequencies high means the antenna size will automatically reduces here. This is one of the advantage here. Next one is the low power consumption. Power consumption is very less in case of the microwave range here. Next was the effect of the fading is less. That is the reducing the attenuation. When we transmit from one point to other point, the fading effect is very less in case of the microwave range there. And also the in case of the data communication of the binary information, for suppose we want the data communication means what? Communication between the two computers here. That is called as the data communication, and that is transmitted in the form of the binary, that is zeros and ones here. In that particular application, it requires a very wide bandwidth. Therefore, the microwave range is the suitable for that data communication also here. And next is the biggest benefit of the microwave radio transmission is the large amount of spectrum space available for the new applications or the new communication services, because it is fully, it is not congested. The huge amount of the space is available in the spectrum here. Therefore, for the new applications, we can adopt these microwave frequencies here. That these are the some of the advantages of the microwave here. Now, disadvantages. What are the limitations or the disadvantages of the microwave signal? The first one is the microwave frequency circuit design is complex. Whatever the circuits are there, to design those circuits, it is complex compared to the ordinary frequency signal here. And the working with the microwave equipment requires the special knowledge and the skill. Ordinarily, how we are dealing with the electronic components like the transistor, resistor, diode, in the same fashion, we cannot deal with the microwave equipments because they need some special skills here. They need some special skills as well as the knowledge. Therefore, anybody cannot handle these. They need some training here. This is also one of the limitation here. Next is that there will be power loss due to skin effect. That is, due to the skin effect, the power loss will be there. What is this skin effect? We'll study. That is their definition. Due to this skin effect, the power loss will be there. And in the microwave signals are easily reflected and diverted by the large and small objects. If in between some small objects are coming, easily these signals are reflected and diverted. The direction will easily changes there. Therefore, this is also one of the limitation here. And next is the even rain, snow, fog and other atmosphere conditions greatly absorb and attenuate the microwave signals. Means all the atmospheric conditions, these are affecting the microwave signals. This is also one of the limitation here. And in the conventional components cannot be used at the microwave frequencies because of its lead inductance and the inter-electrode capacitance. Conventional components means what? Our electronic conventional components like the transistors, op-amps, diodes, resistors, all those things we cannot use in the microwave signal range here because of its lead inductance and the inter-electrode capacitance. We will study this also. What is this problem? Actually, later we will study that one. Due to this problem also, we cannot use those devices. Therefore, for the microwave, we need the special devices only here. And also for the transistors do not function properly because of the transit time effect. Transit time effect, the transistors also unable to work correctly. This also we'll see later. The microwave signals travel in the straight line. Therefore, communication range is limited to the line of sight range. Line of sight range means what? The line joining the observer's eyes and the particular destination point there, that line of sight distance. Therefore, the microwave transmission, it depends on the line of sight. If the particular receiver is out of the line of sight, means the signals cannot reach the receiver there. Therefore, antenna must be very high for the long distance communication here to cover that particular range. Now, application where the microwave signals are used here. In the communication field, microwaves are used. In the remote sensing, that is for the weather forecasting. In the heating purpose. In the medical field also these are used. And in the radar applications. And in the telephone communication, microwave relay links. In all these fields, the microwave radio telescope, these microwave signals are used here. Now the communication means what? Suppose we want to transmit one signal, if it is out of range also, the microwave signals are radiated towards the satellite, that is called as the uplink frequency, and the satellite will again re-radiate the signal towards the receiving antenna, that is called as the downlink. That is to radiate these, the microwave signals are used here for this communication purpose. Next, the remote sensing means for the weather forecasting, whether the heavy rainfall or the some any other weather soil moisture, to measure the moisture of the soil and all. These microwave signals are used in the radar application also. And in the application of the microwave signal as the heating, the microwave device. At home we will use in the kitchen the microwave, correct? Oven. That is for the heating application, the microwave signals. That is the heating application. Next, in the microwave signals in the medical application are, this is used for the treatment, diagnostic and the data telemetry also. Means to diagnose. Diagnostic means what? To find out what was the disease. That is called the diagnosis. And after finding the disease, it is used to treatment purpose also. Microwave signals are used for the treatment purpose also, and also for the data entry here. Therefore, in case of the scanning and all, that is the brain scanning, all the scanning processes, the microwave, bone scanning, brain scanning, all those, the microwave signals are used here. Now this completes the first session, that is introduction to the microwaves. What are the different frequency ranges we have used, what are the applications, what are the advantages and what are the limitations of the microwave. In the next session we will go to the that is we'll learn about the what are the different limitations of the microwave signals.